Is about the XY plotter that our group made for the design project for Team Robot. Here you can see the breadboard that everything's hooked up to. We have the Arduino that's used to control all the logic up here in the top right hand corner. We have all three of the drivers that are needed to drive the three stepper motors that are on the project itself. And we have some terminals here to connect the motors to, so that it's easier for us to switch things around if we need to. Because the motor leads aren't exactly the easiest thing in the world to work with, so it helps to make it a little bit easier for us. We also have a row of headers up top here so that we can read inputs from the plotter itself, so that we can react to certain events that might be triggered and things that can happen appropriately, so that we don't, destroy the plotter while it's doing something, or so that we can react to where exactly the paper is on the plotter itself. Here you can see some of the hardware that's actually on the plotter itself, like the stepper motors. All three of the stepper motors are identical, so I didn't bother including shots of all three of them. We also have bump stops. There's 4 of these on the plotter, 2 for each axis, 1 on the positive and 1 on the negative end. And in the middle here you can see our setup for the marker, which includes a servo, a photoresistor that's attached to a nail to keep it a little bit closer to the surface. That helps us to detect whether or not we're on the paper, which is pretty helpful. I'll explain that here in a second. And we have a marker mounted to this device so that it can raise and lower and actually draw things on the paper. A marker is used instead of a pen or a pencil or something like that, so that we can mitigate the amount of vibration that happens, because this thing vibrates a lot. Our software is divided up into 2 main parts. There's a front-end Python program that presents a console interface that allows you to control the plotter. You issue commands. The commands are validated, and they're resolved into either a list of calls to the plotter or a single call to the plotter. It gets turned into data that can be sent over the serial interface, and after being sent, it will wait for some sort of acknowledgement back over the serial interface from the Arduino that's controlling the plotter itself. The approach that we took allows us to create this console style interface that allows you to type in exactly what you need the plotter to do. It also allows us to abstract away certain functions that the plotter may have so that we can make it do higher level things. For instance, if I say draw a capital A, instead of having to make repeated low level calls, I can abstract those away into a method called draw capital A or something like that, so that when I call that method, those calls will be made in succession on their own. The second part of our software will be the firmware for the Arduino, which is written in Arduino and C++. Arduino and C++ are very similar. Arduino is actually turned into C++ before it is compiled and put onto the Arduino itself. In the beginning, initialize plotter is called. That's where the plotter will zero itself on the bump stops. It will travel diagonally across itself to find the piece of paper. Once it finds it, it'll measure on the Y and X axis how long the paper is and where the paper stops, so that it has a pretty accurate idea of where the plotter is. And then we programmed in some offsets so that when we start using the marker, we don't mark on the plotter itself, because obviously the marker and the photoresistor are not in the same spot, but the measurements are taken relative to the photoresistor. In the loop of our Arduino program, the Arduino will sit in a wait state until enough serial data is gathered that I can parse it and turn it into a command. If the command is ill-formed or something like that, it'll go back to the wait state. Otherwise, the command will be executed and an acknowledgement will be sent back over the serial interface.
So come here and say